good lookings. Welcome back to Armani's Math. This is lecture number 9. We are going to talk about the law of sines. The law of sines. Help me out in the chat. Tell me, what do you see? Okay, some of you are saying that. What else can you see? I'm not going to say what are you saying, but just for others to okay. I've seen the word repetition. I've seen the word shadow. 30 or 30, 60, 90. Hopefully that did not like come across as a nightmare or something. Yes, there is an optical illusion in this thing. Look closely, you'll find out. Okay, anyways, here we go. Here's the warm-up. Today's focus is the law of sines, and we are going to talk about 2 items. The first one is the area of a triangle. The second one is the law of sine, how to use the law of sine in events such as not right triangles. Okay, so that's what we're going to talk about is warm-up. And for the timer, I'm going to put the timer here. I believe this just requires some time, so I'm going to put 2 minutes here for you. Focus and use the time wisely. As always, any answers, you could put them in the chat. Okay, so find the area of a triangle given the base and the height. So in this case, you are given a base and a height. It's pretty easy, and you maybe draw your first something like that. H is 7, and the base is 10. So if you want, this is 1/2 area equals. Area equals 1/2 base times height, and height is 7, so it's 1/2. Got the 10 with the H. I'm sorry, which is 7. Hello, 7. And I'm a big fan of simplify before you multiply. So the 2 and the 10, this one goes to 5. I mean, there's nothing wrong with you multiplying, but make your life easier when you simplify. So basically, you end up with area equals, I've got 5 times 7, which is 35. Whatever the thing is, whatever the measurement is, let's say this is meter or inches, has to be something unit squared, okay? Unit squared. Where the area is always squared. If there's no unit, you just put unit squared. Okay, number 2. It says solve for x. This is when you cross multiply. Before I do the cross multiplication, I'm going to talk about one other thing for this here. You solve it obviously by cross multiplying, but I want to show you that this is exactly the same as flipping these, meaning the 19 over 12 and the x over 18. These 2 are exactly the same proportion. These 2 are proportion but are equivalent. Okay, so always keep that in mind when you think about these things. These are the same. This side is the same as this side. Anyways, that's not what we want, but just a side note that these 2 ratios are the same. You just flip, but you gotta flip both of them, not just one of them. Okay, so that's gonna should give you the same answer. You could try it, by the way. You could try it and then find out. So this is x times 12. This is 12x equals 18 times 19, or 19 times 18, doesn't matter. 18 times 19. And somebody's getting me a number here. So I've got 12 equals, is that 3, 4? 3, 4, 2, I think is one of you are giving me. Okay, some of you are giving me numbers 3, 4, 2. Let's check here. Guys, I need you to be involved, so please in the chat, use the chat to give me some numbers. I got 18 times 19 equals 324, and Ivan is correct. You divide this by 12, divide this by 12, and you get yourself x equals but that by 12, you're gonna get 28.5. Yep, you're right, guys. I see some of you start writing here. That's very true. That's the solution for this one here. Okay, moving on to the third one. It says in triangle ABC. In triangle ABC, we have measure of angle A. Let me see, how can I do this better? Let me actually take this on a new page. Partial, we're going to take this on a new page. All right, and just going to put it in the middle here, and then let's see what's going on. In triangle ABC, I have a measure of angle A and angle B and angle C. So obviously I have to choose a different color for that dude here. Okay, let's choose this one here. So let's see, and I'm not, is this, what is the measure of angle C? That doesn't really matter, but shouldn't look like right triangle. Let me reverse my action here. It shouldn't look like a right triangle because it doesn't actually look like a right triangle, just a triangle. All right, here we go. A, and perhaps I need to fix it just a little bit because A is really huge. If you looked here, A is very huge. So maybe if I am very careful with drawing as much as I can with this tool that I have here, maybe one of them is really, yeah, something like that. So this would be angle A because it's really huge. Opens up to the longest 1, 2, 2. And let's say, again, it's not drawn to scale, but let's say this is B, and B is 17. How much you think is the third angle? Angle C. And I see some of you are giving some answers here. How much do you think is this angle gonna be? And I see that this angle here, angle C. So measure of angle C is, yes, I see that a couple of you have 41s, which is correct. Yes, that is true. 41 is correct. All right, here we go. Objective today, students will be, or student or viewer will be able to determine the area of a triangle given side, angle side, SAS. Also use the law of sines to solve a triangle AAS, angle, angle side, and angle side angle, ASA. All right, so that's what we're going to be doing today. Please pick a point from the objective and put that in the chat. Pick any word from the objective and put that in the chat. And I need you all please to participate. So I would feel that you guys with me. There's a few more. Okay. SAS, left sign, law. Okay, here we go. That's perfect. All right. When do you use this stuff in life? Well, it turns out to be that this dude here, which is the tower, the tilting tower of Pisa, is tilted. It's tilted, and the question became, I mean, is it going to fall? So we're not too sure. So they were trying to calculate, obviously, a lot of laws, not just the law of sine, but one of them was the law of sine. Try to save this monument here, which they actually did. So I think now we're about 5 degrees tilted, 5 degrees, or just about. But we've heard it's good for about maybe a couple hundred years now. After the injection that they've done in the under the ground and some other things that they've done to it. So that's one application for the law of science, basically engineering and architecture in this case. But can you think of other? If you can, you could put that in the chat. Okay. What we know thus far from also the warm-up, if you did that, you know that we have an area formula for the triangle, which is 1/2 base times height. 1/2 base times height. The issue with h, height, if I don't have a right triangle or I do not know the height, how would you get this h here? So if you looked closely here, this is the h that we're talking about, this particular line here. How do you get this h here? Well, think of it this way. Let's say that this is my triangle, and I'm going to put that down here. This one, I'm going to use this. Let's say that, oops, that's not exactly what I want, but something similar to that, which means I've got to come from the bottom to the top, just like this. Okay, I'm looking at the one at the left now. Okay, look at left. So this is h, and this is the b, the base. This is the c, little c. And so now the question, how do you find h? If you have this angle here, 73, how do you find this h? Well, if you remember the law, if you remember actually the trig ratio, the sine, so you needed something with a ratio of opposite over hypotenuse, which is the c, because the c, by the way, is given. C has a value, which is good, 2.96. So C I have, B I have, I don't have H, the hypotenuse. So now what are you going to do is you're going to think of it in a different way. How can I get that H? Well, it turns out to be H is this piece here, C sine A. So I want to just explain this a little bit here. So here's H, and here is your B, and here's your C. This is angle 73 again, and we just said that sine 73 degrees is going to be the opposite H over C. So I know obviously sine 73, I could plug in this in the calculator. I know C, so how do you get H? Well, you just cross multiply. You cross multiply that. This is just like that, like this. And you will end up with H, right? H times 1 is H, is actually going to be C, little c, sine 73. And that's exactly what you take. You take this amount. You take this amount here for H, and you plug it back into your, there we go. You just take this amount and plug it back here. So you're kind of working around the system to find what you need. Okay, this is where this formula came from. This is how it was developed. So you're just using the basic knowledge of the base times height. We use this formula to find the area of a triangle given the lengths of two sides and the angle between them. So this formula here is used when you have two. This formula here is used when you have two sides given and an angle between them. Two sides and an angle between them. Obviously, this side is given, this side is given, and an angle between them would be this guy here. That's what you use this for. Okay. So do you have, obviously there's more than one iteration. There's not just one side that you could find, but it turns out to be you could find all three sides. I should say the area given either of the two sides in the triangle. Another important thing to know here is uppercase is always reserved for the angle name. Excuse me. Uppercase is reserved for the angle name. So this is B, this is C, this is A. Lowercase is reserved for the side lengths. So the side lengths, which, by the way, the angle A faces its side. Remember the notes that I was singing? Ah, that's A. Ah, that's B. So every angle opens up to its corresponding side, whatever opposite of it. That's its side. And you label that by lowercase. So angle A faces little a. Angle B faces little b guy down here. Angle C, uppercase C, faces little c. So the side again is lowercase. Lowercase for the side, uppercase for the angle. Okay, now here's the iterations of the law. It's the same law. I should say it's not a law. It's the area formula. It's the same area formula, except you're just alternating the sides that are given to you. If you're given side B and side C, then this is the angle in between them, which has to be different than B and C. Obviously, if you're here and if you're here in this triangle and you're given this side, which is, let's say, the first one here, first example. You're given side B and here's side B, and you're given side C. You're given side B. I'm sorry, that's not side C. You're given side B and side C. See that? This is side C, little c. You're given little b. So obviously the angle between them has to be different than A and different than B. It will be the angle A in this case. So basically, if you remember what we've done, so you have a side, you have another side, and there's an angle bound between them. Basically, that's what we're doing, okay? So, and it doesn't matter which side, by the way. It could be AB, BC, could be AC, AB, doesn't matter. But that's the, and then you play with the iteration of the sign of the angle between the two sides. Let's take an example on that. Find the area of the triangle and round to the nearest tenth. Okay, so we're going to find the area of this triangle here. Let's try to play with that. All right, let's play with that. Area equals. Let's see what's given here. Well, I don't have any labels. You make up your label. And there is no really right or wrong way. Perhaps alphabetical order means from the least to the greatest. It could mean that. So if this is true, then maybe we could name this guy little a, and this guy here little b. This has to be C. And this obviously this is A. That means it's facing angle A. This is side B. That means B is up here. This is angle C. So right off the bat, I am given side side B, and I'm given side A. Excuse me. And side B and side A. So now let's just plug in this into the formula itself. 1/2, and I have 1/2, and then I have side A. Let's just put A and B, sine C, smaller a little bit, sine C. Okay, so this is 1/2. A is 3, excuse me, and 5 for B, sine, and then a 40 degrees. All right, so hopefully there is something I could cancel, but there isn't in this case. So 3 times 5 is 15. Divide that by 2, sine 40. Depends on your calculator. Some calculators are smart enough to know that you're actually multiplying and then dividing. Some of them tell you, no, I can't do that. You just have to do the top and then divide it by the bottom. So it just depends on what's your calculator doing, okay? I did it here, and it turned out to be that I have myself. Anybody is getting some answers here in the chat? Oh, Lord have mercy. I see some of you are typing. Some are typing. Okay, I see some numbers there. I did that actually, and I came up with approximately, we use this tilde here to say approximate, not exact. Approximately got 4.82. And because it's area, so it's unit squared. In this case, they gave us meters, so it's meter squared. Okay, if that's not what you got, then slow down and then go back and then try to see where did you do wrong. Okay. Okay, here we go. Why don't you try that? Try that. Find the area of this triangle and then round to the nearest tenth. So let's try this together here. Maybe you could help me. Maybe you could help me in the chat. I see some of you are saying 48. Try this again, Ethan. R. Are you putting sine 40? Check if you're in degrees, you're not in radians, and some other things like that. The default setup for calculators, by the way, is radians. In this case, we want to talk about, we want to turn it, we want to change the mode to degrees. So also that could be one thing that could mislead us. Anyways. All right, let's talk about this here. That is frozen, not sure why, but right, I got disconnected. It's okay. Let's see, how can I? Apology. Looks like we're disconnected. Let's try to connect again. There we go. All right. So let's see what do we have here. Area equals. Let me just do some labels. Put some labels here. Maybe this is A. Not sure. A. Remember, this is arbitrarily chosen. You choose that. B. Maybe this little C. So that's uppercase C, uppercase B, uppercase A. Okay. And for that, I said when half A, B, sine C. I see some of you got some answers here. Did I? Yeah. That one should be, I see some of you are giving me. Okay. 1/2 A, B, sine C, and I have a half, and then I have an A, which is 8 times 12 sine of the angle C, which is 86. Okay. Again, depends on the calculator, but 86 degrees here. And I would definitely simplify first. So the 8 and the 4, that's going to give you a 4. 4 times 12 is 48. So that's what I would do. So I would put 48 times sine. This is an 8 here. Times sine 86 degrees. Okay, and you multiply that out, and I got myself something like approximately. I'm looking at your chat at the same time. I am looking at 47.9 meter square, feet squared in this case, because they give us the measurement feet squared or square feet. Okay. And here is my answer. Right, 47.88. Hopefully when you watch this again, you pause and you go through it on your own for two reasons, one of which obviously there will be an assignment based on the lecture, and the second one is for you and for your personal education. Okay, there we go. Let's talk about the big one today. The big one is called sine, the law of sine. I'm not going to talk about the derivative, how you derive this law, but we're going to present it as just the law of sines. Okay, there's obviously a lot of math behind this one. Could be presented in a different format, a different time. But anyways, what we have now is this here. So you say sine angle A divided by little a is the same as sine angle B divided by little b equals to sine C angle C divided by little c. Okay, and I don't want you to shouldn't look overwhelming, because you always have to use only two of them at a time. You can't use all three of them. Doesn't make any sense. So you just have to pick two to use according to the need, whatever you need. Maybe the first two, maybe the last two, maybe maybe these two. It just depends on what you need. Maybe the first and the last, that also would work. The first and the last should also work, like this one and this one. But you only use two fractions, two fractions, not three of them. Okay. Another thing that I did allude to in the beginning, is the fact that you could actually flip these. But to flip this, you have to flip these as well. And you have to flip these as well. See what I'm saying? Still going to be true, but you could flip it. You could say this is A divided by sine A equals little b divided by sine B. Okay? How is it presented in different textbooks? Well, it actually depends. So probably this one is more common, but these two are exactly the same. This one and this one are the same. These are the same. Here's something that we're going to cover today, and we need to pay attention for time-wise. I took a little slower time on the warm-up and stuff. But anyways, over here, we are going to focus on two cases. So you use the law of sine for two cases in our lecture today, which is angle, side, angle, given angle, angle, side, side. And then the second one is angle, side, angle, side, angle. There is a third one. It's called the ambiguous case, which is side, SSA, which gives you either no existing triangle, or could give you one triangle, or it could give you two cases for triangles, two different triangles. It just depends. So anyways, we're not going to discuss number 3. And by the way, there is no ASS. Yeah, don't ever think about that in math and geometry. Anyways, here we go. This says use the law of sine to solve. The word solve here means you need to come up with 3 angles. 3 angles. Okay. And my handwriting. And 3 sides. That's the word solve. Solve means you come up with 3 angles and 3 sides. All right. So that's what we're going to do. 3 angles. I'm going to start with the first one. So the first one, is going to be, I think I need some room here. So I am going to capture this dude and put that in a new page. Hello. Okay. Excuse me. Need to capture. Sure. Put that in a new page. And I'm not sure what's not giving me that page. But it's okay. That's fine. We're not going to give up. Anyways, I could do it here still. That's fine. So let's say I have to solve this triangle. First thing first, I have myself some labels here. So this is F uppercase. That means little f is here. Little f is 50. If this is E, little e is here. And D is little d is here. and you see the setup here. So obviously, I need to come up with the third angle. So that's the first thing, angles. Angle E. So I would add things up. I would say, for example, it's up to you how do you do things, but perhaps you're going to do 33 plus 28 plus measure angle F equals 180. You add all of them to give you 180, right? Measure of angle F. And that's going to give you 61 plus, I'm going to just say F equals 180. F is going to be equal to 180 minus 61, and angle measure of angle F is going to be 119. Okay, so we know that for sure. We know 119. I need more room, so I have to clean things up a little bit. So we just know now that we have 119 over here. Watch the video and you know how we got that. 119. Okay, now we're gonna pick a side. So let's say, for example, I wanted to find side D. I want to find side D. Okay, well, you find side D by using the law of sine. So let's set up the law. Okay, it says sine D uppercase divided by lowercase d is going to equal to, give myself here more room, is going to be, by the way, you pick things. So I'm going to say sine f, for example, divided by little f. And here we're going to have to cross multiply. So like this, like that. And that's going to give us d, little d, times sine f. I'm going to slow doing the first one slow, but I'm going to have to speed up a little bit afterwards. This is times little f equals little f times sine of uppercase d. You divide both sides by sine f because you just wanted the d by itself. You want to isolate the d. So you divide both sides by sine f. And that's going to give you the d itself is going to equal to, I'm going to do it here. The d itself is going to be f, little f, sine d divided by sine f. Okay. So now d equals what? Well, what is f? Well, a little f is 15. Sine, what was d? What was the measure for angle d? 33. Divided by, what is sine f? Well, f is 28. Okay. So now d equals 15 times sine, and I've got some numbers here. 15 times sine d, sine 33 divided by that. That should give you about 17. And we're approximating here, so I'm going to put 17, approximate, not equals, approximate, that little tilde is approximate, is 17.4. Okay, 17.4. I've found side D. Side D. So this guy's 17.4. Does that make sense? Well, let me see. 28 degrees opens up to 15. 28 opens up to 15 side. So 33 is going to open up to more than 15, right? Sings a higher note. 15, 33. So obviously it makes sense. Okay, just logically makes sense. Okay, that's one of the things that you check for. All right. That was 119, by the way. It doesn't look like we're gonna go through all examples, but it's okay. I'm fine with that. So this is the first thing that we do, and let me do the other one, which is now the other side. So we've got Does anybody remember how much was D? Can you put that in the chat? How much was D? How much was D in the chat, please? 17.4. Good. So now I'm looking for, what do you think I'm looking for right now? Which one is missing? Which one is missing, do you think? That's right. Isaiah's right. E. I'm looking for E. So if I want to do that, so I would come here and say sine, use the left sign, E divided by little e equals sine f divided by little f. Can I use sine d? Of course you could. You could put sine d divided by little d. That's okay. It's fine. Okay, so sine e, and obviously I'm looking for e, so I'm going to cross multiply. Cross multiply. By the way, you cross multiply when you have an equal sign between two fractions. So now we have e equals there's a step I'm missing. There's a step here that you have to come up with, but there, you should end up with e equals f, little f, times sine of e. Divide that by sine f. If you're not sure how I get this one, watch the video. Just the very previous side should tell you exactly how did we do with the cross multiplying. Okay, so now f is 15. 15. Sine e is angle e. How much was angle e? Can somebody tell me, please, how much was angle e? Yep, 119. Thank you. So I've got sine 119 divided by sine, and f, what's f? Well, the angle f is 28. Okay, so e is going to be approximate e little e 27.9. 27.9. Okay, so that's not true. Hold on a second. This is not a point. It's not a point here. Up. Hold on. 27.9. So basically, you're saying that this guy here is 27.9. Does that make sense? Well, let's check. Let's logically check. If 33 opens up, let's say the little one here. If 28 opens up to 15. Okay, little, okay. Then the 33 is going to open up to a little bit more, which is 17. That makes sense, right? And finally, the 119 has to open up to, yeah, like really larger, right? Not like 15, not like 17, because it's 119. It will open up to a longer side, which is in this case 27. So logically, it makes sense. Computation-wise, you just have to check. Maybe I made a mistake or something. Sometimes I actually made a mistake right before I did the lecture here, and I was just I just thought this is a different angle, and I put a different angle. Came up with wow, I have to fix my mistake, which I did. So just watch that. Also, just don't forget that your calculator again is in radians mode. So change that. If you get a different answer, check your calculator mode to see if you are in the correct mode, which is degrees. Okay, now we're going to do an example together. Promise me. Okay, and for this one, actually, I will, believe it or not, oh hello Armani, what are you going to do? Well, I'm going to open up the chat so you guys can talk to me. Oh, come on, Armani. Are you going to do that? Are you really going to do that? Yes, I will do that. So here's what I'm asking you to help me with. Angles are uppercase. Sides are lowercase.
Okay.
So this is an uppercase J here as the angle. So what do you think is the lowercase should be for J?
To the 12.
That's correct. That is perfect. So J is this amount. Okay, how about H is given H here, K is given K. That's all. Okay. Somebody else help me, please find angle K. Measure of angle K. All right. Should I call or should you guys just volunteer?
42. It is 31.
Okay. I wonder how did you get up with how did you come up with 31?
By subtracting. Oh no, by subtracting 107 and 42 by 180. So K can equal
Gotcha.
31.
So others, you could say 42 plus 107 plus this angle. You just give maybe K equals 180.
Yeah.
You add these two, and then you will end up with angle K. Measure of angle K will be 31. Thank you. That is correct. Oops, 31 degrees.
You're welcome.
Okay, good. Let me use the big eraser and now I needed somebody to help me out find which one do you think we're gonna do? I'm missing side H and side K. So let's say, for example, we wanted side H. What's the setup for side H? Please grab the microphone and start to share. Somebody else who did not talk today.
Oh.
What's going to be here? What?
On the top, it would be sine of where is it? Sine of 42, because it's the angle of H that we have to put there.
You're right. You're right. You're like one step ahead of me.
I'm so sorry.
So sine H divided by H, and then you're gonna use. I mean, you could use J, you could use K. It's up to you. Sine.
Yeah, sine of J over lowercase j.
That's right. Yeah. Divided by lowercase j. Okay. And you, as I said, you just were one step ahead, but we're gonna cross multiply, and that's gonna give me times sine of uppercase j divided by and because you want H, so you have to divide by sine j. Okay. And divide this by sine j. Obviously, now we're looking for H by itself. It'll be j sine H divided by sine. This is an uppercase j, by the way. The uppercase j. There we go. Uppercase j. And when you plug in them, so I've got actually, what's j? I have 12. Sine H is, how much is H? 42. Divided by sine J, sine J is 107 degrees. And how much was H, you guys? Does somebody come up with a number here? How much was H? Approximately. Let's see the chat here. H was how much? I know some of these take time because you have to plug them in a calculator and stuff. Here's what I got, 8.4. H is 8.4. Okay, I'm gonna just speed up just a little bit, okay? So we have two things here. Obviously, this is the first one. How do you find the angle? And this is the second one. You find H. This is exactly what we've done here. You cross multiply. Let's multiply. And h sine 107 divided by 12. And that should give us 8.4. If you want to solve for k, you could also choose this half of the fraction of the law, which so you're gonna kind of basically put k and h together, and when you cross multiply, you will end up with k equals 6.5. 6.5. There is, I mean, obviously these need you to focus and concentrate. And we made mistake. It's okay. Just have to go back and fix the mistake again. My advice for these is, again, to find a very slow, to do them slowly at the beginning, and then to pick up the pace. I do have a couple other examples to show, but not today, since our time is almost running. So when you go back to these, make sure that you're watching carefully here. Okay, here is number 5. Number 5, I'm not going to do it. I'm just going to give you the solution, and for you to look it up. It's as if a quiz for you. This is number 5. You should end up with 105. Side links for number 5. Before I put that, I'm just going to give you a pause, maybe a couple seconds to do it, so you have a chance when you watch the video to pause. And then here are some answers for the Q and the R. Okay, here is the self test, I guess, or self quiz. You quiz yourself. These is also a couple ones that you this is going to be actually an assignment that you have to turn in with you explaining how did you solve these two triangles. Okay. So when you watch the video, just make sure that you pause here at the quiz, and then this is going to be part of your assignment. Okay. Let me just, the answers are here. I'm not going to hide the answers. The answers are here. You just have to find, you have to explain it, how do you find the answers. Okay. Well, as we always do, there's 1 minute hope with Armani. Doesn't comes from my heart to yours. And in it, I just share with you that things are sometimes tough and rough in life, but we know that God is faithful, and He's going to help us through this. Not just the corona, by the way, not just the virus or the pandemic. Even in our own lives, we have our own pandemics. So we just have to commit ourselves and trust that He's going to take care of us. Okay, guys. As always, do not forget to like, subscribe, and smash the like or the share button. Usually these lectures are not open for everybody, so if you find somebody who wants to benefit from that, just share the link until it's open publicly. Okay? Be blessed and